Hey, welcome back. Today, let's work on some inverse trig functions. And again, if you want to start right with the questions, just skip ahead a little. I just want to give some brief little reminders about some of these. First, in terms of where we started, these questions are so much easier if we've been doing a good job practicing since the beginning, right? Do we know our radians like the back of our hand? And of course our degrees, but more specifically, radians are the new ones, right? Do we know the coordinates around our unit circle? And can we evaluate, can you quickly tell me what the sine of 3 pi over 4 is, right? Today, we're basically going to go backwards. So before, we'll use that example. I said sine of 3 pi over 4. So we're saying, what's the y value when I'm at 3 pi over 4? Well, I can look on my unit circle over here, and I see, okay, my y value is root 2 over 2. All inverse trig functions are, as you learned, well, it kind of says it's the inverse, right? Before, my input, right, was a degree, right? Input was a degree or a radian. I guess I should just call it an angle, but yeah, let's do that. Instead of talking about degrees and radians, my input was a angle. And what I get for an output? Well, my output, I got some x or y coordinate, right? In cosine, it was an x coordinate, right? My input was an angle, I got an x coordinate. In tangent, my output happened to be a y divided by x coordinate. And we did their reciprocal functions as well. That's a big thing too. Inverse trig functions, right? We're switching the input to the output to the input is not a reciprocal, right? Reciprocal is 1 over whatever function we were talking about. So keep those separate. And again, some textbooks write it with this, looks like a -1 power. It's not. Please don't think it's a -1 power. It's just denoting the inverse. And then it's also, some books you'll see the arc sine of x, or the arc cosine of x. And the most important thing that you probably thought was a little bit odd are your restrictions. And those are basically just things you need to memorize, right? What's allowed for our range in the questions we're about to do. And one of the reasons we even have these restrictions, well, let's do an example and then we'll quickly talk about it. Because again, I'm not trying to reteach, I just want to practice with you. But let's look at this question. All right, so we said earlier we had an angle and the output was, especially for sine, was a y coordinate. All right, let's just change it around. So now my input here, it says the inverse sine of 0 is going to be what? So now this over here, this is a y coordinate. So my output this time, right, my output is going to be an angle. So where did I get, right, at what angle did I get a y value, an output of 0 back when I was doing these? Well, my y value of 0, that's right here at 0 degrees, right? 0 degrees or radians. Let's do a little better one where we don't get the same answer. Let's say we had sine of, the inverse sine, of, how about a half? All right, so again, this here is a y coordinate. I want the angle. So what angle was I at to get an output, a y value of 1/2? Again, the output back in our previous lesson. All right, well, let's see. I can look at this. Again, we're not going to have this in front of us, of course, but I think in the beginning it helps to think about it. Well, my y value of 1/2, oh, that was 30 degrees or pi over 6. Right, so all I'm doing is switching it. The weird part I started to talk about before is that I have these seemingly random restrictions. And we haven't graphed sine and cosine yet, but let's say they look something like this. They look like this. Oops, this is really bad. They're symmetric above this axis. All right, if you remember from algebra or algebra 2, when you have an inverse, what happens? Well, the inverse, and maybe I'll do it in red, the inverse, you had this y equals x line that it seemingly flipped over. So sine and cosine are both going to look something like this. Again, this is a super rough sketch, right? What's wrong? Is this a function now? Before this was a function. I could do my vertical line test. What happens when I do my vertical line test here? Not a function. And that's why we have these restrictions, because as long as I have these restrictions, I can call these are functions. They match all those rules. So that's where these restrictions come from. I just like to say it at least once for those curious. But without further ado, let's get to practicing. All right, I'm going to hide all this good stuff so that we can really use our brains now. And I made it annoying examples here, or at least that's the way my students would talk about it, because we're not going to use degrees. Let's practice our radians. All right, well, we already did that one, so we don't need to worry about that. All right, so now the inverse cosine of 0. So what angle, again, all my answers, so maybe just answers, some angle, right? So we need to think of this as an x or y divided by x, and my answer is an angle. So what angle am I at when I have a cosine of 0? Well, my restrictions, inverse cosine of 0. For cosine, inverse cosine, I gotta be careful, is just my top two quadrants, from 0 to 180 or 0 to pi. So where am I to get an x value of 0? Well, that must be my x value of 0 is right here, right? What degree or radian is that? Pi over 2. Right, at pi over 2, the x value is 0. All right, and maybe you can write it out in the beginning. Some students, I recall, like to write this out. Before they know the answer, they like to, that's not the eraser, they like to write out, eraser, come on, help me there. Cosine of some angle is 0, right? That could help, right? I'm switching these. Well, pi over 2 is the angle. 0 is the way we traditionally saw this, right? Cosine of some angle gave me 0. Well, that's pi over 2. All right, moving along. Tangent, inverse tangent of 0. All right, well, in tangent, I can go up to pi over 2 in my positive direction, right? I'm going to mark this as pi over 2, but it's actually, I can't go to pi over 2. And I can approach negative pi over 2, right, in this direction. All right, so what angle am I at to get a y divided by x of 0? Well, that's 0, right? What are my coordinates at 0? Well, y is 0 and x is 1. So I'm at 0 radians. All right, cosine, inverse cosine of 1/2. Okay, so again, and I suggest drawing your restrictions each time just to kind of jog your memory. So I want an x value of 1/2. So what angle am I at to get a x value here of 1/2? What would that be? Well, we can double check too. Is it the longer side? No. So that is pi. I want to say 60 degrees too. That is pi over 3. Okay. Sine, inverse sine. I'm really struggling with saying this. And my, this is root 2, right? The root should be on top, but I didn't have a nice, easy way to do that. Inverse sine of root 2 over 2. So again, sine is the same restrictions almost as tangent. I can go to the ends here, right? Down to negative pi over 2, up to pi over 2. All right, so where am I to get that root 2 over 2? Well, those are my 45-degree angles, right? So I'm at 45 degrees, also known as pi over 4. Notice my horrible dependence on degrees as well, and then I have to convert it to radians. Tangent, right? Up almost to pi over 2, down almost to negative pi over 2 down there. All right, where do I get a inverse tangent of 1? So what angle did I get y divided by x of 1? Well, the only way to do that is when my x and my y were the same number. Well, what was that? That was this number, right? Same answer as my last one, pi over 4. Right at pi over 4, my x and my y are the same value, and that's how I get 1. All right, cosine, inverse cosine of negative root 3 over 2. All right, well, I'm somewhere over here. If I'm negative, I also know I'm not in my first quadrant, so I'm somewhere here. This is the longer side, right? So if I have a longer side for my x value, what angle is that? Well, some people may call it 150 degrees, or it's 5 pi over 6. How about inverse sine of 1/2? All right. I know I can go up to pi over 2 or down to negative pi over 2. And where am I when I get my taller side? My y value is the shorter piece, right? 1/2. Well, I'm right here at pi over 6. Moving along. How about, interesting, tangent of root 3. Well, that's not an actual coordinate around my unit circle there, right? I had some y and I divided by some x and I got that. And if you remember back to last lesson, we had to do some simplifying to get this. So if I drew a picture, there's only two spots I could be. I have a 50-50 chance. I know I'm nowhere over here, first of all, right? I can go up to almost pi over 2 and down to almost negative pi over 2. Well, in my fourth quadrant, tangent's negative, right? Because the y is negative and the x is positive. So I know I'm not down here. So to get root 3, we kind of already, we can't be at 45 because that's what we did earlier, right? At 45, I'm trying to do an x here. It's not the answer. I get an inverse tangent. That would be 1, right? 1 would be in here if I'm at 45 degrees, but I'm not. So that means I'm either at 30 degrees, right? Or I'm at 60 degrees. And again, in radians, pi over 6 and pi over 3. All right, so maybe I don't have any guess. Let's guess, and we'll try 1. And so we're at 30 degrees, we're at pi over 6. My x value is the longer one, right? So I'm at root 3 over 2 if I labeled this coordinate over here, comma, half. All right, let's see. Is this right? Well, how are we going to check? Let's divide, right? Y divided by x. And my x is root 3 over 2. All right, that means multiply by the reciprocal, right? So let's flip this, 2 over root 3. My 2's cancel. And I have a 1 left and a root 3 on the bottom. Oh, that's the same, right? And why is that the same? That's not the same, actually, sorry. If I rationalize here, multiply by root 3 top and bottom, I get root 3 over 3, root 3 times root 3 is 3. Is that the same? No, not the same. It turns out if I did this same process at 60 degrees or at pi over 3, I would get this root 3. So we can do this after, and we might as well look at it right now. Anyways, I'm talking to myself here. My answer is pi over 6. Pi over 3. And, after all that confusing talking, let's actually see why, just to make sure. So when I did that, I didn't get the right answer, right? So let's erase this and show you why. So before we just tried at 30 degrees, well, let's write the coordinates out at 60 degrees or at pi over 3. Well, there, my x value is the short side, so I'm at half. And again, if it's already clear to you, skip ahead. So let's divide, right? Tangent we said was y divided by x. What angle am I at to get this root 3? Well, now it's this way. Flip, right? Multiply by your reciprocal, 2 over 1. Bam, right? Now you're at root 3. So that's why it's the pi over 3. So I don't memorize these. I just sometimes do a quick little division to get the answer. All right, what angle am I at to get a negative 1 for sine? Also known as, what's the inverse sine of negative 1? Well, I know I'm over here somewhere. Up to pi over 2, down to negative pi over 2. Where am I going to get a negative 1 for my y value? All right, where am I if my y value is negative 1? Where's y? Down here. What's down there? Negative pi over 2. Move along. Inverse tangent. Again, not up here. I'm going to go up or down. Pi over 2, negative pi over 2. Where am I to get a y divided by x to be negative 1? Well, the only place where the two values, y and x, are the same is at negative 45 or negative pi over 4. Right? Because the y is negative and the x is positive, so that's how I get the negative pi over 4 out. Cosine. Inverse cosine of negative 1. Okay, well, I know I'm not over here because my negative x value is in my second quadrant. So where's what angle am I at to get an x value of negative 1? Well, it's over here, right, at pi. All right, the inverse tangent of negative root 3 over 3, we basically killed that over here, right? We did it both ways, except now I'm not in my first quadrant like I was before, right? I'm in my second quadrant. And so if I just put a negative in front of that old answer, I'll get the same thing, right? At root 3, that was pi over 3. At the root 3 over 3, that was pi over 6. That was what we did that first time. So I have negative, right, I'm down here. That's kind of a big pi over 6, but that's okay. Negative pi over 6. All right, coming to the end here, sine of negative root 3 over 2. All right, I know I'm not in my first quadrant. I must be in my second quadrant. I should have filled in my inverse signs here. I can go to the end, right? So I have the longer side is my y value. Well, where's that? That is at negative pi over 3. And finally, kind of similar question, but be careful of our restrictions, right? I can go from 0 to pi. Where am I to get a cosine, to get an x value of negative a half? Well, that would be at 2 pi over 3. All right, hope these questions help. Again, learn your unit circle, right? Know those radians. Be able to do our last practice session with just, normal sine, cosine, tangent, secant, cosecant. And it makes these so much easier if you already are good with those. Hope this helped. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples, or if you want another topic to be covered.